Hello everyone, this is Tejas Raj from Sri Venkateswara College of Engineering and I am here to discuss about what is four-stroke engine. So we'll go with the introduction of four-stroke engine. So let's move on. Now we'll move to petrol engine cycle. In this cycle there is a four types. One is intake stroke, which is also known as suction stroke, and another is compression stroke, and then power stroke, and then exhaust stroke. We'll come to intake stroke. During the intake stroke, the piston moves downwards, drawing a mixture of air and fuel into the cylinder through the open intake valve, in which when the intake stroke starts, the piston is at TDC and moves downwards. In this cycle, inlet valve is open and exhaust valve is closed. Now we'll move to compression stroke. The piston then moves upward, compressing the air fuel mixture. This increases the temperature and pressure, preparing for ignition. In this compression stroke, during the stroke, the compression of fresh air comes into it and it starts from BDC to TDC. So it goes from down to up. Then during the stroke, both inlet and exhaust valves are closed. Then we'll move to power stroke. The spark plug ignites the compressed air fuel mixture, driving the piston downwards with tremendous force, producing the engine's power. In this power stroke, at the beginning of the stroke, the piston is in TDC. During the stroke, piston moves from TDC to BDC. During the stroke, both inlet and exhaust valves remains closed. The power impulse is transmitted down the piston to the crankshaft through the connecting rod. This causes crankshaft to rotate at high speed. Thus, work is obtained in the stroke. Hence, this stroke is called as working stroke. So, another is exhaust stroke. Finally, the piston moves upward, pushing the burnt gases out of the cylinder through the open exhaust valve, completing the cycle. In the exhaust valve, at the beginning of the stroke, piston is in BDC and moves to TDC. During this stroke, inlet valve is closed, but exhaust valve is open because the smoke should go outside of the engine. When the piston reaches the TDC, the exhaust valve closes and this completes the cycle. Now we'll come to diesel engine cycle. So in diesel engine cycle, the diesel fuel is injected directly into the cylinder during the compression stroke. The high pressure and temperature inside the cylinder ignites the fuel, causing it to burn and drive the piston down for the power stroke. The diesel engine cycle consists of four stroke. One is intake stroke or suction stroke, compression power, and exhaust. The high compression ratio of a diesel engine is typically 15:1 to 25:1, is what allows the air fuel mixture to ignite without a spark plug. So in this, actually what's going on is, in diesel engine draws only air during the suction stroke, and also the injector is employed to inject the fuel at the end of the compression stroke. Then the compression ratio ranges from 15:2 to 25:1. Then it is accomplished by the compressed at which will have been heated due to high compression ratio to the temperature higher than the ignition temperature of the diesel. Then the compression of fuel takes place approximately at constant pressure, works on the theoretically diesel engine. So let's move on. Now we'll compare both petrol engine and diesel engine. The first point is power output. Diesel engine typically produce higher torque and power output compared to petrol engines, making them more suitable for heavy duty application like trucks and construction equipment. Second point is fuel efficiency. Diesel engines are generally more fuel efficient than petrol engines, allowing for better mileage and lower operating cost, especially for long distance driving. Third point is emissions. While modern diesel engines have improved, they still tend to produce higher levels of particulate matter and hydrogen oxides compared to petrol engines, which is a concern for environmental impact. The fourth point is cost. Diesel engine have a higher upfront cost due to the more complex fuel injection system and other components, but the saving in fuel efficiency can offset this over the long run. Also, comparing with the diesel and petrol engine, the working system is different comparing to petrol and diesel engines. Like in petrol engine, draws mixture of petrol and air during suction stroke, but in diesel engine draws only air during suction stroke. And also the carburetor is employed to mix air and petrol in the petrol engine, but in diesel the injector is employed to inject the fuel at the end of the compression stroke. And in petrol engine it consists of a ratio from 7:1 to 12:1, but in diesel engine the compression ratio ranges from 18:1 to 20:1. Then coming to the petrol and air mixture, is ignited with the help of spark plug in petrol engine, but in diesel engine it is being heated due to high compression ratio to the temperature higher than the ignition temperature of the diesel. And then coming to the, it works on theoretically Otto cycle, and it works on theoretically diesel in diesel cycle. Intake stroke. First one is air intake, second is fuel injection, third is cylinder filling. During the intake stroke, the piston moves downward, creating a partially vacuum in the cylinder. This draws in a mixture of air and fuel through the intake valve. The fuel is partially injected and the cylinder is filled with the air fully charged, ready for the next stage of for the engine cycle. So let's move on. Now we'll move to compression stroke. First one is air intake. Air is drawn into the cylinder during the intake stroke, as I told, and then compression. The intake valve closes and the piston moves upward, compressing the air fuel mixture. And also comes to the high pressure. The air fuel mixture is compressed to a high pressure and temperature. During the compression stroke, the piston moves upward, compressing the air fuel mixture in the cylinder. The increase the temperature and temperature of the mixture, preparing it for the power stroke when the fuel is ignited by the spark plug. As you can see in the images, this is the engine which will be installed in our bikes or cars. Next we'll come to the power stroke. The power stroke which tells about piston moves downward. Another is pressure builds, and one more is crankshaft rotates. In power stroke, the piston moves downwards, creating a vacuum that draws into the air fuel mixture. The rapid combustion of the mixture pushes the piston backward, generating the power that turns the crankshaft. Another is pressure builds. It builds the pressure created by the burning fuel air mixture, forces the piston down, transmitting torque through the connecting rod to the crankshaft. The power stroke is the most important part of the 4-stroke cycle. Then it comes to the crankshaft rotates. As the piston moves downward, the crankshaft rotates, converting the linear motion of the piston into the rotating motion and powers to the vehicle or machinery. So let's move on. Here comes exhaust stroke. Valve opening. The exhaust valve opens, allowing the spent combustion gases to be expelled from the cylinder. Then piston movement. The piston moves upward, pushing the exhaust gases out of the cylinder through the open exhaust valve. And then the cylinder is cleared of the exhaust gases, preparing it to the next intake stroke drawn in fresh air fuel mixture. As I told in the beginning, let's move on. Now we'll move on. What are the advantages of 4-stroke engines? So one is higher efficiency and another is lower emissions, operations and longer lifespans. So one is higher efficiency. 4-stroke engines are more efficient, converting a higher percentage of the fuel's energy into usable power compared to 2-stroke engines. This results in better fuel economy and lower emissions. Then comes to lower emissions. The distinct intake, compression power and exhaust stroke in 4-stroke engine allow for better combustion control and reduced pollutants like carbon monoxide, hydrocarbons and particulate matter. Then longer lifespan. With fewer moving parts and less stress on components, 4-stroke engines typically have a longer service life compared to 2-stroke designs, reducing maintenance cost over time. These are the advantages of 4-stroke engines. So let's move on. Here comes the application of 4-stroke engines. First one is automobiles. 4-stroke engines are widely used in automobiles, from cars and trucks to motorcycles and scooters, providing efficient and reliable power. The second one is electricity generation. One is 4-stroke engines are commonly used in generators to produce electricity for homes, business and industrial applications. Then comes to marine applications. 4-stroke engines are employed in various marine vessels, including boats and small water crafts, offering power and dependability. So these are the application of 4-stroke engines. So thank you everyone for watching this video. Thank you.